Okay, so let's get started. My name's Omar. This is Orion, and we work at Intel. We work in the Visual Computing Software division. We'll be talking about developing and optimizing games for netbooks. So let's get going with that. How many people here have a netbook? It's good. You're the right crowd. Are you... Okay, so the agenda for this session, what we're going to try to cover is pretty much in this slide. We think that you probably fall into one of these three categories on the right, and it's you either have a game that you've created for another platform, maybe a phone of some sort. You have an idea for a game, or you have a game that's already developed that runs on Windows. So what we'll cover in this session is it's basically around Windows netbooks. We'll cover a lot of some CPU optimizations, some graphics optimizations specific to netbooks, and then we'll also tell you how to get your game out there for all the millions of netbook users. And so let's get going. So what am I talking about when I mention a netbook, right? So here's a general idea of what most netbooks look like, or what you can expect to find in a netbook, right? They generally have a smaller keyboard, around a 10-inch screen with 1024 by 600 resolution is pretty average. You have like a full web experience. You can access Flash, HD video, things like that. They're primed for digital distribution. They don't have an optical drive. So most of the stuff that you load on a netbook, you usually just download it and install it that way. It's about the latest netbook, like the one that we're running this presentation on, is average of about 10 hours of battery life. They usually come with Wi-Fi, Bluetooth. In the future, we expect to see more netbooks come with WiMAX as well. And you can assume that there's at least a 1.3 megapixel camera and a mic attached to the lid of the netbook. So these are some characteristics that are common in netbooks that are out in the market. So speaking of the market, how many netbooks are there actually? So far there's been about 40 million netbooks shipped, right? So why do you care about developing for netbooks? Well, right, there's millions of netbooks. There's more coming, projected by 2013 to be around 139 million. So it's a really good market to hit. About 77% of online users own a netbook currently. If you think about other popular products that are out there, like an iPhone or Wii, the adoption rate for the first 6 months for netbooks was way higher than those other popular products. So just to give you an idea of why you should care about this platform as well, if you're thinking about these other platforms and you're kind of drawn to it. So millions of netbooks, people are buying them like crazy. So what is a few ways that Intel is trying to help you as a developer once you have a game or you develop a game is we have several things that you can do. There's the Atom Developer Program that you should join. The idea with this is, and you'll all have information on your seat about this, but the idea is that you join the program. Intel has created an app store so that when you develop a game, there's a validation process so that you can push your game to the netbook users, and all the games and applications that are on the app store are guaranteed to run well on a netbook. So the idea is you sign up for the developer program, you can sell your game or game components, right? So if you have a efficient math library that you've created or something, you can also sell that kind of stuff as well. You can create your full game. Right now, the App Store is available in the U.S. and Canada, but it's soon to be released worldwide. So there's an SDK that you can download to get your game running on a netbook. This might sound a little daunting, like, oh, there's an SDK, but in reality, all that it is at the moment is there's nothing new that you really have to learn, because what you're developing to, what you're targeting is Windows, right? So if you develop anything that runs on Windows, then you just have to adapt your game so that it runs well on a smaller screen, taking, in fact, these characteristics. And then what the SDK helps you do is just connect your game to the App Store so that you can sell once you go through the process. And it's just like the connection to the App Store. So your game can just be like regular C++ or whatever, and you're fine, right? Like, you don't have to learn a new language. You don't have to learn something else. Or in that sense, like, Flash games as well will be valid. We're working on getting that through the validation process as well in the future. So if you have a Flash game that you've developed, or you have a C++ game that you've developed and runs well on Windows, then you're already there, right? All you have to do now is have to get it validated and go through the process so that when somebody downloads your game, it works well on a netbook. The nice thing is that developers like yourselves, then when you join the program, you get around 70% of the revenue. So it's really nice. And these are some of the websites that are also on the cards if you want to learn more, or you want to stop by the Intel booth. We can talk to you more about the developer program, the App Store, and everything that comes with that, and all the benefits for you as a developer when you join it. So, a few other things that Intel's doing to help you promote your game once you get it into the App Store is we have the Intel Atom Developer Challenge. So it was launched in March 9th, the second phase of this. So you can join the program. It's another opportunity for you to make money off of the game that you're submitting, that you're creating for Netbooks. So there's a ton of opportunities for getting pretty much like free marketing from Intel, right? For you as a developer and for your product. So stop by the booth. There's more information about that, and also on the stuff on your chair. Also, I don't know if you've heard about the Level Up 2010. It's the annual contest, game contest that Intel runs. This year they have a special category for Netbooks. So if you're creating a game already, this is yet another place that you can submit it and get more people to use it, more recognition for your game and for yourself as a developer. So yeah, look into that. There's more information at the booth. So I'll pass it over to Ryan. We're going to show a quick demo that we created. Hopefully by now you kind of get a better idea of like why you should be developing for netbooks, right? Like you as a user have a netbook, but if a developer, you want to take advantage of all the people that are also buying netbooks. So we created a demo we're going to move into a more technical part of the presentation. So we're going to talk about this demo, and we're going to talk about the CPU and graphics optimizations that we found are really helpful to know when we were creating this demo. So here's a T-Rex, and it's the mesh of these fireflies. There's 10,000 fireflies here, and they attach to vertices in the mesh that create this T-Rex. And then after a while, they get scared and they break off. And this is basically an AI simulation where they flock back into the mesh and they attach back to certain points in the mesh to create the shape of the T-Rex. So the idea is we were trying to show an actual game system simulation that you would kind of work on if you were creating a game. So we created several versions. We created a serial version, a version that uses OpenMP to update the fireflies, and we also created another one using threading building blocks. So I'll pass it over to Ryan. He'll discuss more about the demo and cover some of the CPU and graphics optimizations.
Yeah, and thanks, Omar. So basically, this demo uses an AI system, graphic system, and as you'll see, we wanted to do something that could get us easily CPU bound and easily GPU bound, so we can explore ways to experiment, figure out how to get around these bottlenecks, and really understand this platform that is the netbook. Okay, so my slides back up. Okay, so as Omar showed and discussed, okay, so there's millions of netbooks out there. There's a good reason to develop for it. Intel gave you the tool in the App Store to distribute. It's very easy to get your game on there. It's just Windows, so if your game runs on Windows, it'll run on a netbook. But there are a few things to consider. Say you got your game already running on Windows and you put it in your netbook. Okay, it's a good thing to understand what exactly the Atom processor is and what exactly graphics chipsets you're targeting. Obviously, you can't take a really super high-end game that's running on one of those 6-core machines with 3 gigs of RAM and a super graphics card like we have down in the Intel booth. Okay, you're going to have to scale and be, this platform is mobile, highly connected, long battery life, but we're not talking super blazing high-end computation power. So the first thing we're going to look at is the CPU side. So the Atom processor is full x86 instructions, so anything that runs on any of the other Intel cores or AMD cores, anything that's an x86 processor, you can throw it and run it on the Atom. The few things that make Atom unique. One, it's an in-order processor. So a typical big core, like the machines we sell, the giant Core i7, Core i5, Core i3, those are considered out-of-order processors. For those that don't know, basically that means when you're running a program, it can extract instruction-level parallelism. So if it sees instructions, it can run while other instructions may be stalled. It can reorder instructions as it's going through. So this allows you to get some acceleration. This is not included in the Atom processor, one, because that's a large piece of circuitry that takes a lot of power. So what the Atom processor does is going to be in order. So as your instruction stream comes from your executable, it's going to run exactly how it is seen there, no reordering. Each Atom core supports 2 threads, so with hyper-threading. As you'll see, threading can be a big advantage for power utilization, doing things like load balancing, and fully using all the cores. You probably want to run with more than 1 thread. So each core, 2 threads, and each core supports supplemental SSE3. Basically, supplemental SSE3 was the follow-on to SSE3. But the real key thing to know is it supports full SIMD SSE3 instructions. These instructions are what give you the best performance using the computation units on the Atom processor. And the nice thing is SSE3, anything that's been since Intel's been doing dual cores, basically supports SSE3, including everything AMD's done. So it's pretty ubiquitous additional instruction set that you can use. So the other thing to consider is the graphics side. So the Atom is typically paired with one of 3 chipsets. The GMA 945 and 3150, you can kind of think of those in the same boat. The 945 is a DirectX 9C part. We'll go into a little bit more detail about what that is. And the 3150 is the follow-on to the 945. The latest Atom, the N450, is packaged with that graphics chipset. So to get better power utilization, the graphics controller, the I/O controller, and memory controller are all now on the Atom. As you can see, more and more components are getting integrated into the Atom. It'll have better control, better power utilization, and that's how we're getting to that full all-day battery life. And all of that on something that's smaller than a grain of rice. Okay, so I said, okay, there's these things you need to remember. Atom's in order. Okay, we should be using SSE3. Okay, that's a lot of things to consider. Something that does help with this is using the Intel C++ compiler. So as I said, we don't have an out-of-order execution. So if you see on the right, there's some assembly, but it's very simple. What we're doing is we're taking B, multiplying by 7, storing it in A, taking D, multiplying by 7, storing it in C. Okay, that's fine. If you look at the instruction scene, we load B in from memory, and then we multiply by 7. You see there's a potential memory stall there because B may have to go out to main memory to get it, and your CPU has to wait for that to go out and fetch and come back and be ready. Okay, normally on a full-size core, it would see that stall and start shuffling around the instructions for you and say, okay, well, I could load B and D at the same time and wait for those to come in and then do the multiplications. So you could go and order that by hand, but if you use the Intel compiler, it does a few things. One of the things is it'll detect these bottlenecks for you and reorder the instructions so you don't have to worry about this. So it moved the load instructions to the top, so those will be done, and then while B is loading, we issue the fetch for D, and at that time, hopefully B is ready and loaded, and we can start multiplying by 7 to store an A. Okay, so there's a few flags. If you get the Intel compiler, there's basically these 2 flags that I have listed here. These are the ones that say, okay, Intel compiler optimized for Atom. The other key one is it uses SSE3. It says go through and try and automatically use the SIMD, the SSE3 instruction set to try and get the best FPS out of your game and best floating point utilization of the core. Okay, so in our demo, it's kind of cut off at the bottom, but when we used the Intel compiler with these flags, we saw about a 1.2 to a 1.3x speed up in our frames per second. It was pretty easy. We just popped in the compiler, threw those flags in, said build, and off we were going. The Intel compiler is great. You can use it with Visual Studio, you can intermix it, you can generate executables that are really good for Atom, you can make executables that are good for any x86 platform. It's a very optimizing compiler. Okay, so there's a few things I also talked about. Hyperthreading. So each core supports 2 threads. And so with hyperthreading, what the hyperthreading allows you to do is to run 2 threads at the same time on the core, and it will try and interleave their operations. So if you have one that's like really integer heavy and one thread that's really floating heavy, you can utilize all the execution units at the same time because it'll schedule those threads to use them together. What does this do? Well, it helps alleviate some of the lack of the out-of-order processing. If one thread stalls because it needs to go get something else, the other thread can come in and use the execution units that thread would use. It also helps, especially with things that have a lot of I/O latency, because, again, one thread will probably be waiting around for disk reads or whatnot to finish. The other thing is the Atom processor supports the full SSE3, even a supplemental SSE3. So this gives you faster floating point. So when we did our example, we wanted to use the SSE3. Well, instead of going through and hand-coding it throughout all of our algorithms, like in the AI, we was like, okay, we can kind of go, you could go write SSE3, or you can just use the XNA math. XM math is a vector math that Microsoft provides with DirectX. It already takes advantage of SSE3. So we just used that, and we saw, somewhere about a 1.1 to a 1.3x using SSE3. Okay, so it's worthwhile to do these. Now, so games that already support threading, already use SSE3. If you have a game that runs on Windows, uses DirectX 9, you may use threading, you may use SSE3. It'll all run on Atom. So it's easy to just take your app, drop it on there, validate that it's good for this platform. Okay. So that's the Atom processor. Now we should spend a little bit of time understanding the graphics chipsets that get shipped with the netbooks. As we said, the 945 and the 3150, they're basically common. They're both DirectX 9 parts, DirectX 9C to be specific, with Pixel Shader 2. Key thing to note, vertex processing is still done on the CPU side. So the hardware supports most of the rendering pipeline past the vertex processing. So there's a few key things to take away from that. A lot of the load for your graphics thing is still going to be running on the Atom CPU. So it's imperative to take advantage of things that limit what is being done in the vertex processing side. So, for example, when we first did our demo, it's a bunch of particles. We used the DX Sprite utility to do all the sprites, to do the little pixels and the particles for the fireflies on the screen. Okay, when we use the DX Sprite utility, that actually has some work where it gets expanded on the driver side and gets expanded in the vertex processing side. That extra work was actually slowing things down because the vertex processing, remember, is being done on Atom. We were doing our AI on Atom. So we're like, okay, well, we changed it to just use full Q quads. They're just basically, screen-oriented quads, 2 triangles, and past that instead of using the sprite, and we saw an improvement in FPS. Just one of those things to remember. It's worth validating. Take a close look at what your vertex processing is doing when trying to squeeze that extra FPS out because you want your game to really stand out. So it's integrated graphics. I'm sure. How many people have worked with Intel integrated graphics or other integrated graphics solutions? A couple people. There's a lot of documentations online about integrated graphics. So Intel has been talking about this for a long time. Go ahead and visit. If you just visit software.intel.com, you can find a lot of information. But a few key things that you can remember. Compress your textures. Use compressed texture formats. We did this. We saw a significant improvement compressing it. We started out with just a JPEG of our little dot that we use for fireflies. Obviously, if you compress it and use a proper DirectX texture format, okay, we saw an easy performance improvement. This is, for people that have done graphics, this is probably kind of obvious. Try and decrease the amount of data that you're sending to the graphics card, so use things like index buffers, over points, lines, and triangle lists. Okay, the GMA 500 is a little bit different. So Intel, to give a little bit of background, Intel made the N series Atom processors that ship with the 945, 3150s was really designed for the netbook. Intel also released the Z series, so Atom Z 300s and whatnot, that was really designed for mids to go into mobile internet devices and to go in cell phones. Now, that didn't keep manufacturers from picking up and putting it in netbooks. So typically what you'll see is the N series Atom paired with the 945 and 3150 and the Z series Atom paired with the 500. Okay, what's the difference between the N series and the Z series? Not much. There's a little bit of difference. The N1 had a few more features in it, but as far as you're concerned as game developers, you're never really going to see that. The one key thing to note with the new generation that recently came out in this quarter, the N450 Atom processor is the new one. It's more unified. We're going to put it in, try and keep one Atom SKU going forward so we can distribute it everywhere. This one, the current generation supports 64-bit. The previous generation, Atom supported 32 only, and so instead of both. So one thing to keep in mind, if your application is 64-bit, you're going to have to target the most recent Atom or port it to 32. Okay, so on that tangent, the 500. The 500 does do vertex processing in hardware. The only thing that you really need to know between the two is, one, you should really validate on the 945 and 3150, one of those platforms, and you should validate your graphics on a 500 as well. The 500 is the same thing. We're talking DirectX 9C, Shader Model 2, all the same stuff that we're talking about for graphics. They both support the same level of OpenGL. So, they're very similar, but like I said, there's a little bit difference in what's getting done in hardware, so it's worth validating on both of them. This one's probably obvious for people that have done some work, but full screen is important, especially with netbooks that come with Windows Vista or Windows 7 installed. Full screen prevents context switching. It's obviously worthwhile to get the best graphics performance to try and run your application full screen. But it's always not necessarily appropriate. There's a lot of apps you can be selling on the App Store. Okay, so one thing we noticed. So remember, I think I've said it like 5 times by now, so you probably, it was very clear, but the 945 and the 3150 offload the vertex processing to the CPU. Okay, that means when you're running your application, you're doing all your game logic on the Atom core, your driver's running for the graphics cards running on the Atom core, and that's doing all the vertex processing. So there's a lot of work already being scheduled on the core. So when you do threading, you have to be careful. When we did threading, typically with the big cores, any amount of threading gives you huge performance increases. You take more threads, you get better scaling. It works great on dual 4 or 6-core machines. On Atom, you need to be careful about how you use it, especially with these ones, because you already have another thread that's trying to run your driver. It's already trying to do the work to do your vertex processing. So when we did threading, we saw no real speed improvement for the graphics workload portion of it. For something that's doing like a lot of disk I/O, streaming, loading levels, loading content, things that are more streaming media content, using the hyperthreading will give you a big advantage. If you're trying to load down that graphics card as much as possible and load down the Atom as much as possible, just validate your threading, see how it works. It'll run. You don't have to, if you're already using it, don't worry, you don't have to port. But you might see a minor penalty because of the vertex processing on the CPU. Okay. So I've talked about what we can do to optimize for the CPU, what we can do to optimize the GPU. Omar's going to come back up here and talk about a few other unique characteristics when you're optimizing your game, such as things like mobility, connectivity, and screen resolutions.
So one of the bigger things that you have to keep in mind is the screen resolution, right? Like you'll have your game, it runs, it's Windows, it's fine, right? But then you have to scale it down to work on a smaller screen resolution. Here are a few key points that might help with that, and is when you're positioning your elements on the screen, if you're creating like a HUD or something, then position them relative to where you want them instead of putting them in absolute positions. So another thing is only put things on the screen that are necessary for gameplay. Don't put everything that you might think of on the screen. Maybe put like a little menu or something. Maybe these are pretty obvious, but there's a great article at the developer program website that covers a lot of these topics, especially related to screen resolution and dealing with some of the scaling or how to do it correctly. Another point is if you're doing when you're doing your buttons, maybe instead of putting text on to describe what the button does, maybe just use a descriptive icon and maybe use a tooltip instead. A few things to think about is you want to, because it's a mobile device, you want to monitor power and connectivity. So there are various ways that you can do this. You can use Windows API, but Intel provides the laptop gaming TDK that you can download at that website that's listed on the slide. And what that does is it's a wrapper around a lot of the power management functions in Windows. And it's a few lines of code. You add the few lines of code and you can monitor power source, battery life, network connectivity, things like that. A few other features that are added into this TDK that I'll cover in the next slide. But so this is a very simple way to keep track of battery life and power utilization on your netbook. Even though there's the newer ones run about a 10-hour battery life, so that's pretty much a full day. But you got to think about that. Games do tend to drain your battery a lot faster, so keeping track of how that's going, it's probably a good idea. If you need more fine grain control or monitor capabilities, then using the Windows power management functions is a good place to do that. All you have to do is listen for this one event, the WM Power Broadcast event. That lets you know when the lid is closed, when battery life is low, when there's like a big change that has to do with power. So if your device is going into hibernate or suspend mode, then you're able to do something about it before it actually goes into that state. So if you want to save the game or whatever, right, that's really up to you, but you're able to know when that's happening before so that the user doesn't have to lose their progress or anything like that. So another thing with netbooks is that they're really good to experiment with usage models, being that the idea is that you buy a netbook to carry it around with you. If you have a game and you want to play with other players, a good thing that you might want to keep in mind is ad hoc gaming is really pretty good. You might want to look into adding this type of capability to your game so that you can play with other people that have netbooks and things like that. So the idea is that, like I said, laptop gaming TDK lets you monitor power and connectivity, but it also provides this functionality to create a network, an ad hoc network around your netbook. So there's no need for internet infrastructure or anything like that. You pretty much make your device an access point that other people can join, that other people can connect to, and then that way you can have like a little network around your area. There's also the Windows Peer Collaboration API that lets you find other people on the same network. In this case, you would need to be connected to a LAN or something. But it's a pretty easy way to find other people that are on the network and maybe play with them that way. So just keep in mind that you might want to experiment with other usage models instead of just a common like get online, play with other people, things like that. Maybe just based on your location or whatever. So we covered a lot of things today, and one of the things that we want to mention is that when you're doing some of the CPU and GPU optimizations, like you're not alone. You don't have to do like printf statements everywhere so that you know what's going on. Intel provides a lot of tools that let you find where hotspots are, where your graphics is spending a lot of time, and so when we were creating the demo, we used a lot of these tools. So we have several of them, several demos in the Intel booth if you want to stop by. But I'll just mention a few. Is the GPA Intel Graphics Performance Analyzer was developed specifically for games. So if you're creating a game, this is a really good tool to have because it lets you like drill down into DX frame and see all the draw calls and what's being drawn and all that stuff and what's taking more time. There's also in the new version that was released at GDC, GPA 3.0, this other the other tool that lets you instrument your code. So if you're doing threading, or you can instrument what's being done, and you can see the like the workflow of what's happening in your game, so that you know like what's taking more time than other things, and what's running in what thread and things like that. So like we said, the Intel C++ compiler is great. It supports Atom. It does a lot of the hard work that otherwise we'd have to do by hand, and it does it really well. And all you have to do is just build it with this compiler, and it does it. So it really offloads a lot of the work that you'd have to do, or other work that you might have to do for like minor optimizations. So, and the Laptop Gaming TDK, if you want more information, go to the website that was listed on the slide, or just talk to me after the presentation. So let's go. So key takeaways is you want to tailor your game for netbooks. You have a very good idea of what a netbook is, what you can expect, the processor, the graphics chipset, things like that. So you want to keep all those things in mind when you're developing your game, but also that the learning curve is not as steep as you might think, right? There's not anything new that you have to learn. If you get your game running on Windows, then it runs on a netbook. You just have to do these few other things. And there's a lot of things that Intel's doing to help you as a developer that's targeting netbooks. One thing is I talked about the developer program, the App Up Center. So we're trying to help you make your game better and also get it out to people that want to play it. So like I said, the compiler does a lot of the hard work for you. So you should try to use that as much as possible. Use SSC and threading, and just kind of use tools to make your life easier when you're doing all this stuff. So I think that's
So we're going to do the drawing for the netbook really soon. Just real quick, this slide, video recording of our earliest practice dry runs of this session will be available at that website. You can always email Omar, me here. As Omar pointed out, if you want to see the App Up Store in motion, go ahead and come visit us at the booth. Furthermore, if you're interested in signing up for the Atom Developer Program, you can do that at the booth. You get a free T-shirt as well. It also has the advantage of it waives the initial $100 fee for joining the developer program, and then you can really get the tools that you need. Okay, on your seat, too, you'll see there's a USB drive. The USB drive has the slides for this presentation. It has extra resources, some articles and presentations that are useful. includes the SDK, links that you need to sign up for the developer program, and everything should help you get started there. Yes, and lots of literature, reminders. You can sign up here, you can sign up here. You have the address all over the place. Okay, so how are we going to do the drawing? So we have evaluation slips. We take these very seriously. We use these to compare. Any feedback you give us, we'll use when we're doing future sessions. Please take the time, fill us out. It'll help us win a bet. We have a few internal ongoing bets on how we do in these sessions. And then when you've completed this, go ahead and bring them up front. We'll give you a ticket for it in exchange for your evaluation.
All right.
And then we'll do a
Give them to you.
for one of the tickets to the netbook.
So yeah, hand it over to your,
Oh, yeah.
and he'll give you a ticket.
Well, let's go help hand out tickets.
Okay. So any questions? Well, we can do questions after.
Yeah, so we'll do questions. Let's get the evaluations form, the netbook drawn, and then we'll take as much time we have left for questions.
Let me give you a ticket.
Thank you.
There you go.
Yeah.
That's the roll.
Sorry.
Excuse me.
It's actually really cool. So while you all are getting your tickets, handing your evaluation form, I'll take a little bit of time to pimp some of my colleagues' other sessions that are going on. There's a presentation today at 1:30 called Simpler, Better, Faster Vectors. This focuses on microarchitecture optimizations using SSE, SIMD, how to get the best performance. Talks about the Intel compiler in a little bit more detail. So if you want to learn more about those, this is a good session. There's a few other sessions, including in the booth, where you can learn about GPA. This is one where we're talking about using a game and actually applying that tool to SIP5. If you're really interested in learning more about threading, tasking, and really learning how to scale, not only for Atom, but for all the cores that Intel are releasing in our current and next generation CPUs, you can attend Ron Bosner's talk, task-based multi-threading, how to program for 100 cores. I don't think we have any static. Oh, legal, yeah.
That's
Good old legal disclaimer. Key takeaway from the legal disclaimer: do not sue Omar or me or our affiliates Intel.
Yeah. Awesome. Cool. Thanks everyone for giving us your feedback.
Okay, did everyone hand in their feedback? Everyone get a ticket? One. Oh wait, let me put my ticket in.
Ready?
Okay.
Go ahead.
Okay, I imagine the first couple digits are the same. 964 0 3 7.
Ooh.
Anyone? Oh, there you go. Yep. Enjoy. Thank you for your presentation.
Yeah.
Okay.
So we'll take questions now from anyone that's still here.
Is there any multitasking network out there that would compete with iPad?
So the question was, do we believe that the multitasking competes with what's available on the iPad?
Yeah.
Okay, so the multitasking and whatnot supported on netbooks is everything you can do in Windows, right? So standard multitasking you do on your...
Multitask.
Yeah.
No.
So yeah, what the OEMs are doing on netbook is standard, uniform, keyboard, mouse, screen, exactly what you expect from a laptop, just kind of shrunk down. Some OEMs are taking the Atom chipset and putting them in things like cell phones with touchscreens, putting them in other devices. I believe someone is doing touchscreen netbooks, so they're making the screen touchscreen, kind of a convertible tablet PC.
Is there one with the Google Chrome?
The question was, is there one with Google Chrome? I don't know if at this time people are selling netbooks with Chrome installed.
Yeah.
Intel provides Moblin, which is a mobile Linux operating system. So some of them are shipping with that as an alternative to Windows. If you want to see Moblin or that a Linux running on one of these, you can go down to the booth. We have it running there.
Yeah. Right here?
Is there any plan for supporting the Linux netbook with all the tools?
The question is there a plan to support the Linux netbooks with all the tools? Great question. The Intel compiler supports Windows and there's a Linux version. So the Intel compiler will already do that. Most of the Intel tools, like vTune, Thread Vector, Thread Profiler, are already designed to run on both Linux and Windows. The exception being the GPA, the Graphics Performance Analyzer, is designed for DirectX and Windows at this point. And Parallel Studio, which is a set of tools that integrate into Visual Studio. Visual Studio doesn't run on Linux yet, so those tools aren't supported.
Is there any plan for the App Store to come to Linux?
Yeah, okay. And the further follow-on question is the App Store going to be running on Linux? Again, a very good question. Right now, it's distributed on Windows, but with Moblin and other Linux-based platforms, we will be porting to the App Store there as well. So it should be available soonish.
And there's someone on the mic. Go ahead.
I'd like to ask if there's a minimum or a range of hard drive sizes or memory that developers can expect on the netbook.
I think if it comes in with an SSD, it's somewhere in the 80 gig or max range, maybe. If it doesn't, then it's probably 160 or something else. They usually come with a 1 gig of RAM. That's an average. It varies, but that's about an average, at least a gig.
Yeah, it'll evolve over time. You'll see them put more and more memory.
A lot of those decisions are based on the power consumption. So,
the key thing to note is, as Omar said earlier in the presentation, there's no optical drive or whatnot. So when you're talking about distributing this, digital distribution is a good idea, or some sort of USB insert. So again, remember your user has to download their content. So keeping the size reasonable is a good idea. Yeah.
My name is Nicole from Netbook News. So I'm actually looking for anyone who's developing games for netbooks. I want to talk to you after the session. And I've got two questions.
Yeah.
The first, you said that there wouldn't be a difference in developing games for the 500 series, but like there's difference in issues between the 350, the 3250, and the 5. Like just like multitasking, like just like straight up usage. So how can there not be a difference in if you're developing a game for the 500 versus the...
Yeah, really when you target DirectX as your graphics API, for example, it's going to run the same on either. You don't have to really do anything. The really only important thing to remember about those chipsets is they're slightly different hardware. So you want to run your game, your application on both to see that you're getting the desired frames per second and the desired usability. But there's not really much of a coding effort. It may be an extra little optimization effort at the end.
And I have one more question.
Yeah.
He was asking questions about Linux, and I know that Moblin is merging with MeeGo, Nokia. So for game developers using Qt, is where's that going to go?
So The merging those OS is basically Intel will continue to allow that to be an option to be installed on netbooks. You'll be able to use MeeGo, kind of the evolution. Again, a mobile version of Linux designed for lightweight power use, lots of connectivity. As far as game developers is on that platform, you're talking open GL as your graphics API, not necessarily DirectX. So people are using OpenGL. Same thing, the graphics chipsets support that as well. Validated on both the 500 and the 945 or 3150. Same idea, just kind of make sure that the graphics gets the same level of quality and performance you want. But it's basically like a notebook. It's just much smaller form factor and focus on power. So, I mean, if you can get something to run on a notebook, whether it's Linux, MeeGo, whatever you want, you can get it running on a notebook.
Any other questions?
Okay. Thank you, everyone.
Thank you.